So last lecture we discussed about these three kinematic equations for motion of uniform acceleration for rectilinear motion. So if the body is moving in a straight line, that is horizontal direction, then we will use this three equation. If the motion is due to acceleration due to gravity, that means the motion is upward or in downward motion, then these equations becomes, we replace that a, if the upward motion is there, then for upward motion we replace in above equation a as minus g, that is g is acceleration due to gravity, so the value is minus 9.81 meter per second square. So for downward motion, that we replace this a by plus g, that is 9.81 meter per second square for these three equation. That is, if it is downward motion, then we replace a by g 9.81, this a by g 9.81, this a by g 9.81. Then if it is upward motion, then we replace a by minus 9.81 minus g, this minus g, that is 9.81, minus a, the minus g, that is 9.81. So today we are going to solve problems based on these three equations. So the first problem is, a motor car takes a 10 second to cover 30 meter and 12 second to cover 42 meter. Find the minimum uniform acceleration of the car and its velocity at the end of 15 seconds. So the given data is, so for 10 seconds, that is the time is given as, let us say for 10 seconds t1 is time as to cover 30 meter, that is distance is given as, so let us say that s1 is equal to 30 meter, and 12 seconds to cover 42 meter. So let us say that t2 is 12 seconds and s2 is 42 meter. You have to find out the uniform acceleration, that is a is equal to, you have to find out, and its velocity at the end of 15 seconds. So velocity when t is equal to 15 seconds, that you have to find out. So from this, the three equations are v is equal to u plus at, then second equation is s is equal to ut plus half at square, and the third equation is v square is equal to u square plus 2as. So from these two equation, we'll use the second equation as s is equal to ut plus half at square. So from the given data, s is, for the first s is 30 meter, so the equation becomes 30. So here the initial velocity for that is u, so the second is 10 u plus half, you have to find out acceleration a, and t is here 10. Okay, so this equation becomes that 30 is equal to 10 u plus 50 a. So let us say put this as equation number 1. So from the second given data, we will find out from this equation s is equal to ut plus half at square. So that equation becomes this. So let us say put this as equation number 2. Okay, so multiply the equation 1 by 6 and multiply equation 2 by 5, so that this u will be same. Okay, then and we subtract the second equation from the 1. So subtract equation 2 from 1. Okay, so when we multiply this, then equation becomes 210 is equal to 60u plus 360a, then 180 is equal to 60u plus 300a. So we subtract that, so this will be cancelled. So 30 is equal to 60a, therefore a is equal to 0.5 meter per second square. So this is acceleration. We will find out the acceleration first, then next velocity at which the for t is equal to 15 seconds. So first of all, we'll find out the initial velocity. So we'll put this equation a is equal to 0.5 meter square in any one equation. So we put that a is equal to 0.5 meter per second square in equation 1. So that will be, we'll find out the value of u as 0.5 meter per second square. So we'll use the first equation, v is equal to u plus at, that u is already know, a is we all found out. The time t is 15 seconds. At 15 seconds you have to find out the v. So the final velocity will be 8 meter per second square. So this will be the answer of this problem. So we'll find out the another problem, that a small steel ball. So this is for rectilinear motion. This problem is also for rectilinear motion. So the body is moving in upward direction. Then we'll use this equation. We'll solve this problem as a small steel ball is shot vertically upward from the top of the building. So the building is, let us say this is the ground. So this is building, and from the top of the building, so the height of the building is 25 meter above the ground. So with initial velocity u is equal to 18 meter per second. So u is 18 meter per second. You have to find out in what time, let us say, it will reach the maximum height. So from this top of the building, we'll throw the steel ball, okay, in upward direction. So height is from the ground 25 meter. Okay, so we have to require to find out the time t. Let us say the time is t1 when it will be reached at the maximum height. Then second, that is b, you have to find out how high above the building will be rise. Okay, so you have to find out the maximum height, that is the h, and compute the velocity with which it will strike the ground. You have to find out the final velocity v, and the total time is in motion. Okay, so when u is here 18 meter per second, so for the first you have to find out at what time it will reach the maximum height. So it will reach to maximum height, that means when it will reach at maximum height, the final velocity v will be 0. So we'll you have to find out the time t. So that we will use any one equation from that v is equal to u plus at, s is equal to ut plus half at square, and third is v square is equal to u square plus 2as. So here we'll use the either any one of these three equations. So we will use here as here the u is given as 18 meter per second, final velocity v is 0. So we will find out the value of t, that is t1, that is the time required to reach the maximum height. Okay, so from that, so here for upward motion we will use equation as a, replace a by plus g, and if it is downward motion then we replace a by minus g, that is 9.81, and we will solve the problem. So the final value for that will be, so t1 is equal to 1.83 second, then h is equal to 16.5 meter. So this h is from the height from the 20 above the building. So the total height will be this 25 height of building plus 16.5, so that is 41.51 meter. So this is the time required. Then the velocity will be 28.54 meter per second. Then t2, that is time required to reach the ground. Okay, so that is when ball is upward direction, and it will reach when it will slow down from this this highest maximum height to ground. So that the time is 2.91 seconds. So the total time is equal to, so this is final velocity with which it will strike the ground. The total time is equal to t1 plus t2. Here t1 is 1.83 plus t2 is 2.91. So that final answer is 4.74 seconds. Okay.